Mercury is a neglected, abused chew toy of the solar system. It is the innermost rock, parked so dangerously close to a literal thermonuclear reactor that it is actively being tortured by the universe. Despite being treated as the solar system's cosmic doormat, Mercury is arguably the most hardcore, bizarre, and scientifically baffling planet in our solar system. It's not just that tiny rock near the sun. It's a cosmic glitch in our solar system. And today, I am going to break it down from brutal physics to failed assumptions, NASA missions, and why this planet is way more insane than it looks. And how is it even possible that Mercury, the closest planet to the sun, contains billions of tons of water ice? Here's some perspective on just how hard it is to study Mercury. We have sent exactly 3 missions to this planet in all of human history. We've sent over 50 missions to Mars. Mercury gets 3. Why? Because getting to Mercury is one of the hardest maneuvers in planetary science. It's not just about distance. It's about speed. Mercury orbits so fast and is so deep in the sun's gravity that a spacecraft launched from Earth actually arrives too fast to enter orbit. You have to slow down, and slowing down requires enormous amounts of fuel or creative gravitational physics. Mission 1, Mariner 10, 1973. NASA launched Mariner 10 on November 3rd, 1973. It was a string of firsts. The first spacecraft to visit Mercury, the first to use one planet's gravity to reach another using Venus as a gravitational slingshot toward Mercury, a technique proposed by Italian mathematician BepiColombo. And by the way, the man was so clever, they later named the spacecraft after him. Mariner 10 flew by Mercury 3 times in 1974 and 1975, returned over 2,700 photographs, and discovering Mercury's magnetic field, something nobody expected. Then it ran out of fuel and was shut down on March 24, 1975. It now drifts silently in heliocentric space, untracked and unseen, like a forgotten probe ghost. Mission 2, Messenger, 2004 to 2015. 30 years later, NASA tried again. Messenger, which stands for Mercury's surface, space environment, geochemistry, and ranging, launched in 2004. It took 7 years, 1 Earth flyby, 2 Venus flybys, and 3 Mercury flybys before finally entering orbit around Mercury on March 18, 2011. Messenger was the first spacecraft ever to orbit Mercury. Over 4 years, it mapped 100% of Mercury's surface in high resolution, confirmed the water ice in the polar craters, discovered the bizarre, hollow, shallow depressions where volatile materials seemed to have evaporated right out of the surface, and revealed the planet's volcanic history in stunning detail. On April 30th, 2015, Messenger ran out of fuel. NASA didn't try to save it. They let it crash into Mercury's surface at 14,000 kilometers per hour, creating a new crater. A mission that spent years mapping craters ended by becoming one. That's some poetry right there. Mission 3, BepiColombo, 2018 to 2026 and beyond. The most ambitious Mercury mission ever launched, and it's still on its way. BepiColombo is a joint mission between the European Space Agency and Japan's JAXA. Launched on October 20, 2018, it's a stacked dual spacecraft system. ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter. 2 separate probes traveling together, designed to study Mercury simultaneously from complementary angles once they arrive. The journey has not been without drama. In April 2024, engineers discovered the spacecraft's ion thrusters were operating below full power due to unexpected electrical currents in the solar panels. The team recalculated, adjusted trajectory, and added 11 months to the mission. Mercury orbital insertion is now expected in November 2026 instead of December 2025. BepiColombo has already made 6 close flybys of Mercury en route, including a breathtaking pass just 295 kilometers above the surface on January 8, 2025, imaging permanently shadowed polar craters Prokofiev, Kandinsky, Tolkien, and Gordimer that may harbor the ice Messenger detected but couldn't fully confirm. Once in orbit, BepiColombo will investigate why Mercury's magnetic field is offset from the planet's center, whether its core is liquid or solid, and what those strange hollows on the surface are made of. Science operations begin in early 2027. A glorified cannonball. Let's get the disrespect out of the way right up front. Mercury is small. In fact, it's the smallest planet in the solar system. It's actually smaller than two moons, Jupiter's Ganymede and Saturn's Titan. If Mercury hadn't managed to secure its own orbit around the sun, it would just be another oversized moon. Because it's so close to the sun, Mercury is absolutely hauling across the cosmos. Named after the Roman messenger god, who had wings on his shoes, Mercury travels at a blistering 47 kilometers per second. That means a single year on Mercury, the time it takes to complete one lap around the sun takes just 88 Earth days. But here is where the math gets incredibly stupid. Mercury spins on its axis so slowly that a single day on Mercury, from sunrise to sunrise, takes 176 Earth days. Yes, you heard that right. On Mercury, a single day is exactly 2 years long. If you lived there, you'd celebrate your birthday twice before the sun went down. And if you're looking to take a deep breath of fresh alien air, don't. Mercury has no atmosphere. It has what scientists politely call an exosphere. An exosphere is basically a VIP section at a club with no walls, no roof, and a DJ is a giant ball of plasma actively trying to kill you. It's a thin, fragile layer of atoms, mostly oxygen, sodium, and hydrogen, that are constantly being blasted off the planet's surface by the solar wind and radiation. Gravity tries to hold on to them, but the sun essentially sandblasts the planet day in and day out. The ultimate hot pocket, because there is no blanket of atmosphere to trap heat and distribute around the planet. Mercury experiences the most violent, psychotic temperature swings of any body in the solar system. When you are standing on the sunlit side of Mercury, the sun appears up to 3 times larger in the sky than it does on Earth. The surface bakes at a skin-melting 430 degrees Celsius. That is hot enough to melt lead. If you dropped a pizza on the ground, it wouldn't just cook. It would instantly vaporize into a carbonized frisbee of regret. Because there is no air to hold the heat, the dark side of Mercury drops to a bone-chilling minus 180 degrees Celsius. The incredible shrinking planet. If you crack Mercury open, you'll find out why it's the strangest terrestrial planet we know. Earth, Venus, and Mars all have normal, respectable proportions of crust, mantle, and core. Mercury, on the other hand, is basically a giant iron cannonball wrapped in a thin layer of rock. And here's the terrifying part. That massive iron heart is cooling down. When metal cools, it contracts. And because the core is shrinking, the entire planet is collapsing in on itself. Mercury is literally shriveling up like an old, dry raisin. As the planet shrinks, its brittle rocky crust buckles and snaps, pushing up massive cliffs called lobate scarps. These tectonic cliffs stretch for hundreds of kilometers and can be over 3 kilometers high. Mercury is actively giving itself wrinkles because its internal organs are freezing. Ice on the sun's doorstep. Now, prepare yourself for the ultimate plot twist. I just told you this planet gets hot enough to melt lead. So, naturally, the last thing you expect to find on Mercury is water ice. But science doesn't care about your expectations. In 2012, NASA confirmed that Mercury possesses billions of tons of water ice. How is this physically possible? It comes down to posture. Earth sits on a tilted axis of 23.5 degrees, which gives us our seasons. Mercury's axial tilt is essentially 0. It stands perfectly straight up and down as it orbits the sun. Because of this, the sun always sits exactly on the horizon when viewed from the north and south poles. This means that if there is a deep crater at the poles, the sunlight can never, ever reach the bottom. These are called permanently shadowed regions. Inside these pitch-black craters, the temperature has remained at 170 degrees Celsius for billions of years. Comets and asteroids containing ice crash into Mercury over eons, and while the ice on the rest of the planet instantly vaporized, the ice that landed in these dark polar craters stayed frozen forever. It's the ultimate irony. The closest planet to the sun is hoarding a massive, ancient stash of cosmic ice. Why Mercury matters. Here's the part of this story that goes beyond Mercury itself. Scientists have now confirmed thousands of exoplanets worlds orbiting other stars, and a huge proportion of them orbit very close to their host stars. Hot, small, rocky planets. Worlds that look, in many ways, like Mercury. The problem? We can't visit them. We can't send probes to planets 40 light years away. Not yet, but we can study Mercury. Mercury is our best, most accessible proxy for understanding what these close-orbiting rocky worlds are like, how they form, how their magnetic fields work, how their surfaces evolve under intense radiation, whether they can hold water or not. By understanding Mercury, we're actually building a template for understanding billions of worlds across the galaxy. So when BepiColombo finally settles into orbit in late 2026 and starts sending back its data, it won't just be telling us about a small, cratered rock in our own solar system. It'll be giving us a window into how planets work, how solar systems form, and what kind of worlds might exist around stars we'll never physically reach. Mercury is not just a forgotten planet. Mercury is the key. If you enjoyed this deep dive into the solar system's punching bag, do me a favor and hit that subscribe button. Drop a like to pay your respects to the messenger probe whose debris is still scattered across a Mercurian crater. And let me know in the comments which planet we should roast next. Stay curious, stay existential, and I'll see you in the next one.